Okay, so in the last video, we completed the part one of conversions. In this video, we are going to be continuing with them, and this would be the part two of the conversions. Moving on, if we were to convert binary to decimal, this is the given example 1011.0010, which is given in binary, and we have to convert it to decimal. So we are converting a base 2 to base 10. So for doing that, what we are going to do is first we are going to count the number of bits here, ones and zeros, before the decimal point. So this is 1, 2, 3, 4, and 5. We subtract 1 from this 5, 2 raised to the power 5 minus 1, which is 4. So that would be 1 into 2 raised to the power 4 plus 0 into 2 raised to the power 3 plus 1 into 2 raised to the power 2 plus 1 into 2 raised to the power 1 plus 0 into 2 raised to the power 0. So once we come in here, once we have reached the decimal place, after that we are going to be reducing. So basically here we are following the number line system. So to the left of 0 we have negative numbers, and to the right of 0 we have positive numbers. Here what we are doing is, before the decimal place we are having all the positive powers, and after the decimal place we are going to be having all the negative powers. So after 2 raised to power 0 we will be having 2 raised to power minus 1. In this case it will be 0 into 2 raised to power minus 1 plus 0 into 2 raised to power minus 2 plus 1 into 2 raised to power minus 3 plus 0 into 2 raised to power minus 4. Using the calculator, the answer for this comes out to be 22.125. This is a very simple calculation. Moving on, if we were to find from octal to decimal, so octal is base 8, decimal is base 10. So we are following the same technique. Before the decimal point, there are 1, 2, 3, 4, 4 numbers. So this would be 4 into 8 raised to the power of 3, which is 4 minus 1. Again, we will be adding that with 0 into 8 raised to the power 2 plus 3 into 8 raised to the power 1 plus 2 into 8 raised to the power 0 plus 1 into 8 raised to the power minus 1 plus 7 into 8 raised to the power minus 2 plus 6 into 8 raised to the power minus 3. Here 8 raised to the power 0 will give us 1. So when we are adding all of this and putting all of them in the calculator, the answer comes out to be 2074.246094. Here it is okay if we stop at 5 decimal places. Moving on to the next conversion, we are going from hexadecimal to decimal. That means we are going from base 16 to base 10. We are again going to be following the same technique that we were doing earlier. Before the decimal places, there are 4 numbers. Here A represents 10 and C represents 12. B represents 11. So you're following these. So that is 9 into 16 raised to the power 3 plus 10 into 16 raised to the power 2 plus 0 into 16 plus 12 into 16 raised to the power 0 plus 5 into 16 raised to the power minus 1 plus 11 into 16 raised to the power minus 2 plus 7 into 16 raised to the power minus 3. So when we are putting all of these values in the calculator, this is the value that we get. Moving from binary to octal, so we are going from a base 2 to a base 8. Here we need to know that when we are talking about octal, so octal ranges from 0 to 7, and all of these numbers have only 3 significant bits, meaning for 0 we have got 0, 0, 0. For 1 it is 0, 0, 1. For all of these, only 3 significant bit places are required. So here when we have the binary number as 1110010.1010, we are going to be grouping all of these numbers in 3. So what that means is we write all of these numbers down, and then here before the decimal place we start dividing it in this fashion. So it's going away from the origin and here as well. So here 0, 1, 0 would be one group, 0, 1, 1 another, and because there was only a 1 left, so we'll be adding 2 zeros for our convenience. Similarly, over here it would be 101, and then because there is only a single zero, we are adding two zeros. So 010 is 2, 110 is 6, 001 is 1. Then we have 101 which is 5, and 000 which is 0. So that is the only thing to remember is three significant bits. Moving on to the next one, we have got binary to hexadecimal. In hexadecimal, it ranges from 1 to 15, that is basically 1 to F, which means we have 4 bits which are significant. So here we made groups of 4, as you can see here, 1, 2, 3, 4, 1, 2, 3, 4, and another 4 here. So again, here also we are going away from the origin. So that is again really simple. We move on to octal to binary. So here it is very simple. We just expand all of these things. So for 5 it is represented as 101. For 4 it is 100. For 1 it is 001. And for 6 it is 110. Again, because octal only has 3 significant bits, so that is why it is grouped as such. Moving on to octal to hexadecimal. Now, octal is 3 significant bits and hexadecimal is 4 significant bits. So, if we were to convert from octal to hexadecimal, it won't be possible to convert it directly. So, what do is we first convert it into the binary format and then from the binary convert it into hexadecimal. So, here the example that we have is 5423.516, which is base 8. We first convert it to a base 2 and then we'll go ahead and convert it to base 16. Okay, so first of all we are converting it to binary. So this is the binary format here. So this entire thing is our base 2. Now because we have to convert it into base 16, base 16 is again a 4-bit significant. So for that what we are going to do is we are going to be grouping it in one group containing 4 bits. Okay, so once that is done, we get the values of this as B13.A70. This would be the base 16. Now, if we were to do the exact opposite of this, if we were to go from a 4-bit significant to a 3-bit significant, so that is from hexadecimal to octal, we'll do the same thing. We'll take the hexadecimal and we'll convert it into binary. Here is the conversion, and then we will be grouping them in a group of 3 as we've done here, and then we'll be writing what it means in the octal format.
Okay, so this was a long video. Try to make note of what processes or what steps we have been following to solve these questions because not that they are asked a lot in the exams, but these are basic knowledge that you need to have because you will be using these for your lab classes as well. So yes, that is it. Bye.